Okay, so remember everything I just said. And like I said, there's rigid transformations, there's non-rigid transformations. Rigid transformations only change the position. Okay? They only change position. The shape doesn't change, the size doesn't change. Alright? The only thing that's changing is the position. So it might be like flipped upside down, or it might be moved left, moved right. It might be translated up or down. Alright, so you have translations. Translations are a type of rigid transformation that has the effect of shifting the graph of the function. So you're going to shift it right, shift it left, shift it up, shift it down. Okay? That's what translations are. You have reflections. They're a type of rigid transformation which produces a mirror image of the graph of a function with respect to a specific line, meaning y-axis and x-axis. Alright? Now you have non-rigid transformations. Non-rigid transformations are where functions change shape or size. Alright? And it distorts the shape of the graph. And one we're going to be talking about is dilation. It's a non-rigid transformation that has the effect of compressing or shrinking. So it's going to be like, you're going to take it and you're going to, let's say you have a parabola, you're going to squish it down instead of like getting wider. And or you have the ability to expand, right? Where it's like you're taking the parabola and you're stretching it so it gets skinny, all right? So you're going to be able to compress or expand a graph horizontally or vertically, right? So what you guys are going to do is you have this paper in front of you, all right? It is 3 pages, no, yes. 3 pages front and back, so 2 pages. What's on here is a bunch of questions and instructions. Okay? What I'm going to have you guys do, and I'm going to have to show you guys where to get these, is you're going to follow along, you will work together, all right, to answer these questions. I want you to answer them in complete sentences. I want you to answer them in detail. Don't just make like childish answers like it moved. All right, it moved how? Did it move right? Did it move left? Did it move up? Did it move down? How far over did it move? All right. So what this does is it walks you through this so you guys can get your own conclusions, and then after that we're going to discuss our conclusions. Right now, what you're going to be using is an app on the iPad. Okay, the app is called Desmos. It is also on calculators. Not calculators. Computers. There's a website here at desmos.com. So what you guys are going to do is, all right, I have logged you into my account. And what I'm going to do is I'm going to sit back here at the computer. I'm going to show you how to get started in the basics. Okay? So the first thing it says is open the Desmos app, which you guys should all be on, and sign in using your Google account. Eventually what's going to happen is you guys will create Google accounts, and if you have a Google account already, that's fine. But you guys, and then I will share it with you on your Google Drive. That way you can access it yourself. All right. Now, once you're signed in, what you're going to do is you are going to go to Desmos. You're at Desmos, right? So you might have something here. Hold on one second. Let me save this. All right. So what you're going to do is it says, once signed in, open the vertical translations and horizontal translations graph. So what you need to do is this is what your screen would look like, except maybe not any of this or this. You see this part up here, these 3 little bars. Click on that. Up here in the top left corner. Click on that and a list of things will pop up. Okay? What you guys want is vertical and horizontal translations, which will probably be the 1, 2, 3, 4th or 3rd one down. It says vertical, it's the vertical and horizontal translations. You're gonna click on it. It'll probably say open graph. Okay, hit open graph. And it's good. It should look like this. Does everyone's screen look like this? All right. So obviously the first question says, what parent function are you currently looking at and working with in this graphing exploration? Draw an accurate sketch of this parent graph. So I want you to write down the name of that parent graph and draw an accurate sketch. And then you're going to go through the rest of this. When it says, real quickly before you guys start doing stuff, when it says press play on the H slider, okay, you'll see right here where it says H equals 0. It says you'll see like the play button. You would tap play, and you're gonna watch what happens to the graph. All right, and you're gonna just keep watching it for a little bit, and then you're going to explain what happens to the graph as H is changing. All right, and then you keep going through that. Then you're gonna answer. Then it's gonna say press. Then you're gonna pause the H button while it's at H equals 0, and you're gonna hit play on K equals 0, and you're gonna watch what happens when K changes. All right, so you watch that. And then what you're going to do is you're going to go, eventually after you're done with all that, it's going to say look at all the other parent functions. So what you would do is this. All right. See where there's a little red dot up here by this one? You click it, and then you click on this one because it's going to turn on the other graph. And then you can watch what happens. You can do the same thing. All right. See if you can notice it. If you can't notice it right off the bat, see what happens. See if it's the same. Okay, you're going to say this happens. See if it's the same for all the parent graphs. Okay. And then after, eventually it's going to say, okay, open up the next graph where you just click on these 3 bars, you look for the name, and then you click on the name. That makes sense? Okay, that's what you guys are doing for the next 40 minutes. Okay, so we have this function. It's a parabola. It's f of x equals x minus 1 squared minus 3. All right. So we see this function right here, and what we're going to do here is we're going to take this function, and I can't really represent it over here, but what this function is, we're taking the absolute value of f of x. All right. So what we're saying is you have your function, and we're taking the absolute value of the whole thing. All right. So f of x is just another fancy way of saying what value, x or y. Y. Right? So what this is saying is the y values are equal to x minus 1 squared minus 3. So this function is saying the y values are equal to the absolute value of x minus 1 squared minus 3. So when we press this button right here, you see that this new function, the absolute value of x minus 1 squared minus 3, has now been put up here in blue. And it's pretty, I think a lot of you guys that got here quickly saw that this blue part looks a lot like this red part, except that it was what? Except that it was positive, right? What was positive? The x values, were they positive, or were the y values positive? The y values are positive, right? So what happened, so in order to graph this, we did what with this red part of the graph? Say it again one more time, louder, Michaela. So what we did is we took this negative part of the function and we reflected it over the x-axis. All right. And the thing is here, we can put other graphs in here. What would happen is when you take the absolute value of the whole function, every place where you have negative y values, where you have parts of the graph underneath the x-axis, they reflect it over the y-axis. Everything else stays the same. All right. So, for instance, what I could do is we can quickly add a function here. Let's say f of x. Let's see if I can get it right first time. Equals x to the third plus 2x squared. Let's stretch this out some. Say 3. Nope. Say 1/3. All right, there we go. And we're just going to take this and let's move it down 3. All right, so I'm going to just make these go away. And what I'm going to do, no. All right, f of x is equal to, now I'm going to just make this the absolute value now. Absolute value of 1/3 x to the third plus 2x squared minus 3. And what you see is this function, this part down here beneath the x-axis, starting at about -6, got reflected over, and now it's up here. So our new graph
the absolute value of f of x right here actually looks like this. And what you notice is there are no y values that are negative. Why is that? Because we took the absolute value of f of x. We took the absolute value of the y values. So everything reflects over the x-axis. That make pretty good sense? Now, going back to this equation, we also had one where we took the absolute value of x. So the only thing that's changing here is like our x. We're taking the absolute value of x. So what this is saying is, if we take the absolute value of x, -3, this function evaluated at -3 would be the same as it is evaluated at 3. So you put this function up here. And what you notice is that the entire function looks like this. And you notice, and what you should notice is that this entire side of the function, the red function, okay, the entire side of the green function is the exact same as everything in the red function on the right side of the x-axis. All right. So why is this left side different now? Well, we took all these are all negative x values over here, correct? So what happened is we took this red graph, and instead of having -1, -2, -3, we evaluated this same function, but all the negative x values had the same y values as the positive x values. So what happens is you take this right side of the equation, everywhere there's a positive x value, and you reflect it across the y-axis, and you get something that looks like that. All right, so to look at that quickly, let's look at another graph right here. Let's see this graph. So if we take this and put absolute values around all of the x's here, all right, maybe. So we have to just take this, and we'll see if we can copy. We'll copy here. We're going to just take this, and we're going to put absolute value around this x. All right, so we're going to, no, not that, x. Absolute value. All right, so we have that, and we have right there. So let's see what happens. So what should happen when I hit this button? What should this graph look like? Is any of this going to be over here? What's going to happen? The right side is going to do what? Reflect over what? The x-axis? The y-axis. Let's see if we're right. Look at that. So that function actually just looks like that. The right side of this function just reflects across the y-axis, and you get your new function. All right. So were we all able to get sort of an answer for 17 and 18? Now, if we go over here and we look at vertical and horizontal dilations, this graph right here, this one's important. Okay. So if this is the absolute value function, correct? So what we could do here is, let me change something here real quick. Let me go here. We'll count by ones, and we'll count by ones. All right. So you can see this here. So these y values here, all right, this is when a equals 1. When a equals 1, it's just it's f of x equals 1 absolute value of x, which is just the absolute value of x. All right, you'll see that 1 maps to 1, 2 maps to 2, 3 maps to 3, 4 maps to 4, 5 goes to 5, -1 maps to 1, -2 maps to 2, and so forth. All right. So what happens as a gets larger than 1? Okay. Well, so let's think about this. If I were to just graph, let me just do this real quick. Right there. So there's the absolute value of x. All right. So what we have here is this. This function's been changed. The a in front of it's been changed from a 1 to a 3. The a in front of the green function is 1. It's just the absolute value of x. What happened to this y value right here? That 1, 1. It got what?
3 instead of 1.
So the new function, it's at 3. The y value is 3 for x equals 1. At 2, at x equals 2, instead of it being 2, the y value is now where? All right, so 6. And right here at 3, instead of the y value being 3, the y value is now at 9. All right, so let's think about this. What's the relationship right there? This a value, instead of, so it's f of x equals 3 times the absolute value of x. What's happening to all the y values? They're going up what? It's being stretched out. They're being multiplied by a factor of 3. So 1 goes to 3, 2 goes to 6, 3 goes to 9, 4 would go to 12, 5 would go to 15. All right, so all the y values, everything's being stretched vertically. All right, so the conclusion that you want to come to is that when so when you have a number in front of a function like that, and it's like a is larger than 1, the function is being stretched vertically. All right, because what you're doing is essentially you're taking, it's like imagine this is a rubber band. What you're doing is you're lifting this rubber band up and stretching this point up to here, stretching this point up to here, stretching this point up to here, and you just keep stretching every point on that graph up. All right, now if we go look at a is less than 1, because you'll see these points start now being like stretched down. You have to, like, let's just go to half. All right. So if we look at this, make this bigger. All right. You'll see this point right here. The green function is our parent function. It's f of x equals the absolute value of x. 1. X equals negative. Let's just start here. X equals 1. At x equals 1, the y value has been stretched or compressed down to 1/2. All right. Here it was 2. The y value has been stretched down to 1. Well, 2 times 1/2 is 1. All right. Let's look at 3. 3 has been stretched down to 1.5. Well, 3 times 1/2 is 3/2, which is equal to 1/2. 4. It's being stretched down to 2 because half of 4 is 2. So what happens when the value in front of the function, when you're multiplying the function by a value that's less than 1, all right, so it's between 0 and 1, what happens is the function compresses vertically. All right? Questions about that? All right. And then I think the most simple and easy one was, the first one, it just did what? It moves so what's happening here is, like, when h is negative, so when h is negative 5, the graph has moved 5 units to the left, right? Now, here's the important thing that you want to remember. When h is negative 5, your function is actually x what? Is it going to be x minus 5 or would it be x plus 5? Why would it be x plus 5 here? Because what you would have here, if you plug these in, which is what I actually did there, you have, so h is negative 5, correct? You have h, or x minus negative 5. Well, when you subtract the negative, if you can just rewrite that as a positive addition sign, so it'll be x plus 5 to the third power. And then here's my other question. Right now, what is the value of k? 0. It's on the x-axis, right? So really the equation for this graph right here would be x plus 5 to the third. You wouldn't have to put plus k, because k right now is 0, right? You can put it. That would, but just know that, like, in this case, the function's not really, like, if you want to graph it, you wouldn't put x plus 5 to the third plus k, because you can't put a k on your calculator. It'd be x plus 5 to the third. All right? Now, we have enough time, but you guys have to work from here. All right? First of all, you guys are going to have homework. Okay? Who has their paper? Yeah. Okay. So you guys have page 52, 7 through 13 odd, 20 to 30 even, 40, 64 to 66. On the unit, guys, September 23rd. 23rd. All right. Now, some of it is literally just
tell me what the relationship. Like you might, so what might happen is this. Let's just say you had this graph right here, and it looks like that. So it would say the question on your homework might say this. Describe how this graph right here is related to the parent function. Okay? Well, this function is related, this graph is related to the parent function. How? How would I change my parent function, which would be down here? All right, actually, let me do this real quick. So first of all, you have to know what the parent functions look like. Anyone know off the top of their head what the parent function of f of x? Okay. So it's the cubic function, right? So here's what you would need to do for your homework. Explain how you would transform your parent function to get to this graph right here. And what would the equation be? So first of all, here's our parent function, right? How do we need to move this parent function to get it to right there? 5h and 5k. So h would equal what? -5. And k would equal what? 5. All right. So how would you write that equation? Well, we would write that equation. You would have f of x is equal to you have parentheses x plus 5. Plus 5 because it'd be minus negative parentheses to the third power plus 5. So you would say, okay, well, I need to move the parent function 5 units to the left, 5 units up. My equation would be x plus 5 to the third plus 5. And here's the thing. You guys can go check your equations on the graphing calculator. You can check your equations on decimals if you want. All right? So we are going to do, so I want you to do your homework tonight, this weekend. Monday is going to be, let's see what I have on Monday. So let me see. Monday, what's going to happen is this. Monday, we're going to do another activity with the iPad where essentially what's going to happen. I'm going to put a graph up on the screen. You guys have to try to, on your iPad, recreate that graph in Desmos. Right, Lucas? Right, no, the equation will not be up. You'll have to just look at the graph like this. So you would see this graph right here, and you would have to try to recreate it on the iPad in Desmos. All right? And then, so Monday you need to come in with your homework done. We're going to do that. We're going to do 30 minutes of class to use iPads and do that little, that type of activity where you guys have to recreate the graph. And then we're going to spend a little bit of time on some new stuff. All right. So what I need you guys to do is, first of all, we're going to go ahead and take the iPad. But what I want you to do is, actually, let me see. If this does not log me into Google on other apps, then I'm cool with that. You guys do not need to sign out or anything on this. Like Desmond will just stay signed in there, that's cool and stuff. Alright, so what I need you guys to do is you're going to, what's iPad? If you have an iPad that has the number 5 on it, oh, real quick, if you guys need all this stuff summarized, okay, so I was going to, come back to this and we're going to, we have all the stuff right here. All of this is in your book. All these tables right here where it explains all this stuff. So refer back to this if you have questions on your homework. All right? Refer back to that if you have questions on your homework. All right there. In your book. Just go to whatever page the homework's on, start flipping backwards. But you'll see, like, You'll know vertical and horizontal translation that we just talked about today, so you'll get that in that little lot. Packet, keep the packet to refer back to on your homework. So if you have an iPad that has the number 5 on the back of it, I need you to bring that to me real quick. Okay?
In my mind, you're 9.
That don't have 5 on it. Hold on, don't go standing around and stuff. Have a seat, guys. Alright, here's the iPad with number 6 on the back of it.
If we were on there recording, making videos, when you get started on I'm a vampire. I got 3 from you guys. 16. How do you go? I got 3.
It's a 1 pair.
And Mo, I need yours. Alright, so, real quick, focus up here, guys. Football. Alright, so, here's what I want you guys to do. Can you tell me this graph right here, x cubed minus 5, this is the parent graph right here. How would I transform this parent graph to create this? So here's the thing, all right? To move it left or right, what you're doing is you're replacing the x value with x. In this case, if you're replacing it with either plus h or minus h. Right here, x is not being replaced. This is like x cubed, this is the parent function, minus 5. So it's going to shift down 5. So, yeah, so you want to say, so in this case, h, so this is saying like the y values are equal to x cubed. So now the y values are equal to x cubed minus 5. So what happened is, this point would go down 1, 2, 3, 4, 5. Right there. This one would move down 1, 2, 3, 4, 5. This point right here would move down 1, 2, 3, 4, 5. And then same thing with this point, 1, 2, 3, 4, 5. And this one will move down 5, which is way down here. So you exactly look something like that. Alright? This graph. What would happen to that graph? That one. Why did that end there? It's going to move to the right. Alright? Remember, so the initial thing would be x minus h. So this right here would be, h would be equal to 3. Alright? If it is h equal to negative 3, which would move to the left, it would be x plus equal to 30. So, again, what you can do, take all these points, 1, 2, 3, 1, 2, 3, this will move over 3, this will move over 3, and this will move over 3, so you have to be something like that. Alright, what about this one right here? It'll move to the right twice, left twice, right, Sean? You have to get on my YouTube video or whatever. And so it's going to go left 2, up 4. So you go 1, 2, up 1, 2, 3, 4. Alright, this one will go up or left 1, 2, up 1, 2, 3, 4. And you just keep going all the points that you know. Alright? I'm hoping you did it. Describe how the graphs of fx equals g of x, or fx equals x squared and g of x are related. Write an equation for g of negative, or g of x. Right? So this is a little bit tricky. Now, what happens? So let's just say this is f of x equals x squared. What happened here?
They got destroyed. And it flips.
It flips across which axis? So to reflect across the x-axis, what you do is you take f of x and you make the whole thing negative. All right. To flip it across the y-axis, you take all the x values and make them negative.
Oh, I see.
No, those with you to help with the homework. Make sure you do your homework. Don't forget about that. That's bad.
Got it.